All right, in this first example, we're looking at a cosecant. That's actually 2 times the cosecant of 1/3 x, 1/3 being in the argument. First thing I recognize is that both of these numerical values are multiplying, and so we're going to have an amplitude and a period change, but no vertical shift or phase shift. I also noticed that the amplitude value here, this 2 is a positive value, so there's not going to be a reflection either. Okay, so those are the first things that come to mind. Now, what I would actually do in plotting the graph of this is to plot the graph of something I'm more familiar with and then add in the cosecant. We know the cosecant is the reciprocal of the sine, and so I would first plot the graph of y equals 2 sine of 1/3 x, and then we just put the cosecant graph in on the same set of axes. Okay, so just a real quick way to do this. First of all, we've got to figure out the period in the 5 key points. So the period is 2 pi over b, which our b value is 1/3. So it's 2 pi over 1/3. And of course, dividing by a fraction is the same as multiplying by its reciprocal. So that's 2 pi times 3 over 1, or that's 6 pi. Okay? So 6 pi is then our period. That is a weird looking pi right there. There it is. That's better. Okay, so 6 pi is our period. There's no phase shift. So the period is going to run from 0 to 6 pi. And if you consider what your 5 key points are, 0 to 6 pi, then you cut in half the distance from 0 to 6 pi, that's 3 pi. And you cut each of those in half, 0 to 3 pi, cut that in half, it's, what, 3 pi over 2, right? Half of 3 pi. And what's halfway between 3 and 6? Well, it'd be, what, 4.5, which is 9 pi over 2, right? 4.5 is 9 over 2. So that'd be 9 pi over 2. And that gives us our 5 key points. Now you could, if you wanted to, if you didn't know those fractions quickly, you could take 6 pi divided by 4 like we did in the past, and then add that quarter period to 0 and keep adding it 4 times until you get the 5 key points. I would just chop things in half here because I kind of know what those fractions are. Okay, so then we need to plot the graph from 0 to 6 pi. Maybe we'll go with just integer multiples of pi for our units. That'd probably be good enough. So we'll run that out, and we'll just start here. I'll just do pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. Yeah, maybe I'll throw 7 pi in there just so we have a little bit extra, okay? All right, and then maybe I'll throw a negative pi in here as well, just because. Okay, so that gives me my x-axis, pretty much fills in everything I need. The y-axis, I know that my amplitude is 2, and so because this is a cosecant, we're going to want everything above 2 and everything less than 2, negative 2. So we'll put 2 on the graph here. Maybe I'll put 1. Maybe I'll put 3 on here as well. And I'm going to go up to 4, just to give you some values to work with. So there's negative 1, negative 2, negative 3, and negative 4 as well. All right. So, like I said before, I would start by plotting the graph of the sine, because I know the graph of the sine. With my 5 key points, it has intercepts at 0, 3 pi, and 6 pi. So there's 0, 3 pi, and 6 pi. Those are my intercepts. And then I know it has a maximum at 2, at 3 pi over 2. Now 3 pi over 2, that's 1.5 pi, so it's between 1 and 2 pi. So right in there. Okay, so this is our 3 pi over 2. And then the minimum is at 9 pi over 2. Well, 9 halves is 4.5, so it's between 4 and 5. Alright, so that's 9 pi over 2. Alright, so there's my 5 key points. But that's for the sign. Alright, so I'm just sketching this in. I'm doing this sort of dashed and in another color, but just so you can see what the sign would look like over that interval. Okay, so now the cosecant, what I would do to transition to the cosecant is I would think everywhere there's an x-intercept, I need to put a vertical asymptote for the cosecant. So I switch over to my blue marker for the cosecant. I'm not going to redraw the y-axis, but that's going to be one of our vertical asymptotes. 3 pi is going to be a vertical asymptote. That's not very vertical. Redraw that. And 6 pi is going to be a vertical asymptote. Okay, so I've got my 3 vertical asymptotes in. And then I know that my graph of the cosecant is going to correspond to the sign in terms of being positive versus negative. But instead of being between 0 and 1, it's going to be above 1. Instead of being between -1 and 0, it's going to be below -1. Okay, so my cosecant graph shares this intersection point at the max and goes up on either side to the asymptote. And then it shares this minimum point with the sign and goes down on either side to the asymptotes. Okay? So that gives me, so the blue graph is what we actually are looking for here. The blue graph is the graph of our cosecant. The red graph of the sign is just in there as a reference so we can get everything else placed. Okay? Now if I needed to continue this graph, it wouldn't be too difficult to do so. And I wouldn't necessarily need to continue the sign once I've established the pattern for the cosecant. I could just continue this out another, I'll just go half a period just to show you. I could go at 7 pi, that's 8 pi. Let's see, at 3, 6, and at 9, you're going to have your asymptotes. So I'd have another asymptote here at 9. Those are the odd multiples of pi. And then the graph would be up. So I'd have to cut that in half to get my value of 2. And then the cosecant goes up from there, okay? And if I want to continue, the next one would be down, then up, and down, and so forth. And going this way, you go down, up, and so forth, okay? So that should give you an idea of how you would plot the graph of this. Now, if there was a vertical shift or reflection or a phase shift, we incorporate those things in the same way that we would with the sign. Okay, so we would start with graphing the sign, incorporate all those details, and then plot the corresponding cosecant into those regions between the vertical asymptotes. Okay, and that's probably the easiest way to go about graphing a cosecant.